For this section of notes, we're going to start going over the periodic table. Super brief in nature. I know I could spend weeks upon weeks going over the periodic table and its components, but for this course, we are just going to go over the very, very basics, or what I consider to be the very basics of the periodic table. We're going to look at atomic mass, how it's calculated, and electron configurations as well. Thank you guys for bearing with me through the last video. Hopefully it wasn't too painful, and hopefully it was a little better than me being there. I know, contain your cheers and excitement. With that being said, again, like I said, thank you for bearing with me through the ums and the definite out of breath aspects of the video. Hopefully this one isn't as painful as we go throughout. Similar to the last one, if you guys have questions, don't hesitate to ask either Mrs. Kinney or Mr. Wagner or whoever the sub might be today. And if they're unable to answer, please email me. So again, for this set of notes, you guys will have guided notes or a form of guided notes. You guys are going to write in quite a bit. So please, please, please make sure you guys pause the video in order to get down all the needed information. If you guys need to, go ahead and run through the whole slide, see everything that I'm expecting you to write down, and then go back and listen to what I have to say corresponding with each. Do not sell yourself short, okay? Like I said last time, do not skip over any portion of the video. You may miss some information that is needed for the upcoming assignments as well as the upcoming exam. So we're going to start off with section 1, and we are just simply looking at the element symbol breakdown. So what I'm talking about, you look at the periodic table, okay? Looking at that periodic table, what do you see and what are the components? Okay, so first and foremost, the atomic number. With this being said, the atomic number is always going to be the smaller number when you're looking at the element symbol. Sometimes your atomic number might always be listed on top. Other times your atomic number might be listed on bottom. It's just depending on how the periodic table is made. So safe guarantee that you guys are able to come up with is noting that the atomic number is always going to be smaller. Your atomic number also counts for 2 of the subatomic particles that we talked about in the last section of notes, which are your protons and electrons. Remember, your number of neutrons can vary, okay, and you're going to see that within isotopes. Excuse me. But the minute we change protons and electrons, now we're changing elements. So this atomic number is always going to be the same. Next up, the element symbol. Okay, as you guys see looking at the periodic table, sometimes you're just going to have 1 letter, other times you're going to have 2 letters, and now we're getting into the 3-letter elements, especially as we continue to explore the periodic table. And last but not least, the last component of the element symbol is your atomic mass. Okay, opposite of the atomic number, your atomic mass is always going to be the larger number, and how you calculate this is you take the protons and add them to the neutrons. Okay, think about where the protons and neutrons are located. If we look back at section 1, your protons and neutrons are located in the nucleus. Okay, therefore, that's where the atom's mass is going to be, is within that nucleus. Well, what do I find in the nucleus? The protons and neutrons. Remember, with electrons, it has a mass of 0 AMU. Okay, so it does not account for any portion of the element's mass. So like I said, you have your atomic number, always going to be the smaller number, your element symbol, and then your atomic mass. Sometimes they might have the element symbol written out, other times they're not going to. Okay, do not forget about this portion. Alright, write this down again in your notes. Although we have it back in section 1, write it down again. Make sure you guys are aware of the 3 subatomic particles that compose an atom. their charges, atomic mass, and location. Okay. So to start out, again, the proton holds that positive charge and plays a critical role in both the atomic number as well as the atomic mass, and holds an AMU of 1. Your nucleus is where you can find your protons as well as your neutrons. Be careful, a lot of times people want to say, oh, that neutron holds a negative charge, right? That's not the case at all. Your neutrons holds a negative charge, has a mass of 1 AMU, but does not hold a charge. Last but not least, your electrons hold a negative charge, so small, moving so incredibly fast, holds a 0 AMU. But we do find them in the electron cloud. So calculating the atomic mass, section 3. Okay. You just simply take the protons plus the neutrons. This is where we can see that isotopes exist. Think back to that example regarding carbon. You had carbon 12, carbon 13, and carbon 14. Okay. So let's first look at carbon 12. Okay. In carbon 12, I know I have 6 protons and 6 neutrons. So if I take these two and I add them together, that's how I get carbon 12. Alright, and if you guys look at a periodic table, this is the atomic mass you're going to see associated with carbon. Okay, as I stated back in that last lesson, this is kind of the base. Let's say now we look at carbon 14, which we use a lot in carbon dating to figure out the age of organisms. This number right here, your protons, is not changing. Once it does, now we've changed the entire element. So I can safely say that 6 protons exist. So if I have protons plus neutrons, and I know it equals the atomic mass, which is 14, which has been provided, okay, using simple algebraic equations, how do I solve for n? Okay, well, I'm going to subtract 6 from each side. So 14 minus 6. Now I have n equals 8. So this is just one of those examples that your neutrons can vary, and don't assume just because you see 6 protons, you're automatically going to have 6 neutrons. Make sure you read the question entirely and see what it's looking for. Alright, section 4, writing elements and compounds. This one's going to be super important, especially in the upcoming assignments where you guys will create your own atomic compounds and you guys will be responsible for writing your own equations as well as solving equations that I provide you with. Making sure you're writing them correctly is going to be incredibly important in your success. Okay. So the first letter of any element symbol. Okay, so no matter what element symbol you're writing, any one, excuse me, the first letter of any element should always be uppercase. Okay, always, always, always. The second letter and the following letter. So like I said, a lot of times you're only going to see 2 letters, but now we're starting to get into those elements that have 3 present, then should be lowercase. Okay, by doing so, you are distinguishing between the elements present within your compounds. So for example, capital C and capital O, now I know I have carbon and oxygen present. Okay. Let's say I'm trying to tell you carbon and oxygen together, but I just went ahead and I lowercased the oxygen for whatever reason, probably because I got a little lazy. Now I don't have carbon and oxygen anymore, I have cobalt. All right, and that is going to present you with a lot of problems if I'm asking you to do atomic masses, if I'm asking you to do electron configurations. Not writing these correctly will result in incorrect answers. Okay, so make sure you guys are careful and are abiding by the two rules. All right, calculating compounds atomic mass. So we just talked about elements atomic mass. Okay, a few minutes ago we just talked about how the protons and neutrons, adding those two together, I'm going to get the element itself's atomic mass. Now I'm looking at compounds atomic mass. Bear with me here. Okay, hopefully for some of you guys this is review, others it might be completely new information. Regardless of whatever your situation might be, make sure you guys are paying particularly close attention to when it's time to add and when it's time to multiply and add again. All right, so when the elements are simply side by side, all right, what I'm talking about there is when you have carbon and oxygen side by side, distinguished by uppercase and lowercase letters, you're just going to add those atomic masses together. Okay? You guys recall, atomic mass is always the larger of the two numbers. Okay, I'm not working with atomic numbers here. I am not working with the smaller numbers. I'm working with the larger numbers. So for example, sodium and chlorine. Okay, we saw this again as an example of an ionic compound or an ionic bond, but my atomic mass for sodium is 23. My atomic mass for chlorine is 35. I'm just going to take those two, add them together, and get a total of 58 AMU. All right, this one is a little bit more difficult. If there's a subnumber, okay, there's a subnumber present by the elements. So you guys are going to see this coming up. Let's say I have H and a smaller 2 right behind it. Okay, an H and a smaller 2 right behind it. Now I will have an additional step. I need to multiply the element's atomic mass by that subnumber, okay, or by that number provided, and follow through with rule number 1 if you should need to. So for example, water. Okay, I have H2O. And sometimes you're going to see this 2 a lot smaller. Okay, I know on a couple of the worksheets I made, you see them a lot smaller. For whatever reason, it did not maintain when I made this lesson via Smartboard. So whether it's a smaller number, subnumber, or a number following the element, what you guys are going to do now is take the atomic mass of hydrogen is 1, and multiply it by how many molecules or atoms of that element we have. Okay, and then remember it's distinguished by another uppercase letter, so I now have 2 H's, and if there's nothing there behind the O, I know it's only going to be 1, so I can just safely add 16. So now I take 1 times 2 and add it to the 16, and I get 18 AMU. This one's really, really important. So when you guys are completing atomic mass calculations for the course, each is worth 3 points. Okay, you get a point for just showing me your work. All right. Oh, I can do it in my head. Okay, that's fine. I'm not saying you can't. But let's say you guys get 1 incorrect. Well, as long as you showed me your work, wrong or right, you're still going to get a point. Okay, this way I can possibly see, okay, where did they go wrong? Then you also get a point for correct answer, and then a point for simply making sure they are labeled AMU. So one of the worksheets you guys have coming up, you get 3 points per equation. So you take 3 times 15, you get 45. Okay. Again, you don't show me that work, you're automatically down 15 points. Okay. I know it's a lot to take in, so please, 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 if you need to be pausing this video at any time. Make sure you're doing so. What I want you guys to do is, for the remainder of the examples found within the notes, complete them and compare your answers with the partner. Right? You want to make sure you guys get all of these finished, because you do see them repeat on upcoming worksheets as well as the exam. All right, and then the last section we're going to talk about is electron configurations. All right, so the first thing you guys are looking at are the orbitals and the number of electrons that can be held within each orbital. For this course, we are only going up to 4 orbitals. They're represented by S, P, D, and F. Okay. The one unique one is that first orbital. For that first orbital, we know it's only going to hold 2 electrons. If you guys remember back to the first section of notes, hydrogen and helium, those were my exceptions to wanting to hold 8, because they only needed that first orbital. Alright, hydrogen only having 1 electron, helium having 2 electrons, I only need the s orbital. The remainder, though, as you guys can see, hold up to 8 electrons. Okay. So in this course, we will not go above iron, which is element number 26. So that's because I take the S, the P, the D, and the F orbitals, I add them all together to get a total of 26. Okay, so keep that in mind as you guys are asked to illustrate various elements for me in terms of electron configurations. 26 is our stopping point. Going above will result in lost points. Alright, so again, a few more rules to abide by when doing electron configurations. Opposite of calculating atomic mass, you are only going to use the atomic number. Okay. Pretty early on, if you're using the atomic mass, you're going to see we're going above 26. So you're always going to want to use that smaller number. So the steps in order to complete electron configurations for the course, you're first going to write the element symbol and circle it, okay, which is what I've done here with hydrogen. And then I'm always going to start with that s orbital. You can't just skip over it, okay? For whatever reason, you can't skip over it and go to the p orbital and just start placing 8 electrons within. So what's going to happen is, keeping in mind, you're going to start off with that s orbital, which can hold a maximum of 2. Looking at this example, I know hydrogen has 1 electron because that's its atomic number. That's the smaller number. And you're going to represent these with just dots. Okay. Make sure you can clarify the dots. I do have you guys practicing quite a bit with these, and what ends up happening is people start getting a little lazy on me and they just want to give me a little dash. Okay. Well, yes, we can see this here because it's red, but if you're using pencil and pencil, pen and pencil, whatever it may be, I may not be able to tell that you have an electron there. Okay, so when I go to grade it, it's going to be marked incorrect. So you want to make sure you guys have a dot that clearly represents an electron. Alright, the additional orbitals, so let's say I have more than 2 electrons, can hold up to 8. So you want to make sure that 8 are being placed within the corresponding orbitals, and that, again, you're not getting in too much of a hurry and skipping and maybe only putting 7 electrons within the orbitals. So I go over the next 3 examples with you guys. If you guys look at helium, helium is the second element on the periodic table. So I'm going to write in my element symbol, make sure it's written correctly. Okay, capital H, capital E is incorrect. All right away you would lose a point. Then I circle the HE because it represents the nucleus. And again, I start off with this s orbital. S can hold 2. Okay, helium has 2 electrons. With that being said, am I going to need another orbital? No. Okay, not at this point, because now I have helium, which is satisfied with just 2 electrons. The next example, now I add an additional orbital, is lithium. So, as I stated, write in the element symbol correctly. It's the 3rd element on the periodic table. So I have 1, 2. I just can't stop there just because I'm happy with the s orbital being filled. I still have to include that 3rd electron, which now I have to add in that additional orbital. Last but not least, the neon. Writing the element symbol correctly, circling it, right, to represent the nucleus is present, the nuclei is present, excuse me. And if you guys look all the way over to the right, neon has a total of 10 electrons. Remember, the atomic number is what I'm looking at, that smaller number in neon. So in neon, I have 2 electrons in that first orbital. Okay, well, that only takes care of 2 of the 10. And as you guys start getting into larger numbers, if you need to, do the math off to the side somewhere. So I know neon has 10. Okay, I know that first orbital is going to hold 2, which now brings me down to 8 remaining electrons that I need to make sure I have drawn in. And that's what I do in this next orbital. In the next orbital, known as the p orbital, I make sure those 8 electrons are incorporated. Now I know I can safely say that I have 10 electrons present. Again, take your time with this. Okay, if you guys have additional questions, make sure you guys email me, ask the sub, ask Mrs. Kinney. You want to make sure that you can clearly distinguish where your electrons lie. Do not get lazy on me. Okay, and like I said, call that an electron. All right, I will not be able to see that thanks to my age. So you want to make sure that you're clearly distinguishing the various electrons present. Please go back over this video if you need to. You guys are going to review every portion of this video in terms of atomic mass calculations, electron configurations, and there's plenty of review there. I know it might seem tedious, but it's still very, very important, and you guys will see this on the upcoming exam. So good luck. Make sure you guys are working together, not borrowing or stealing answers, and I will see you all soon.